Okay, hi everyone. My name is Marco, and I'm working with the Ethereum Foundation on sourcify. I don't know any one of you knows about sourcify. Ever heard about it? How many developers we have here? Software developers. Okay, nice. So first of all, Ethereum as a protocol, as a software, is a work in progress. So right now, the main focus for the entire Ethereum ecosystem was mainly improving the core of the protocol. Mainly, I know every one of you must know about the merge in the last years, and still other developers are working on optimizing for layer 2s. So I'll also go on that later. But there is still a huge problem right now, and we heard about it in many different talks during these days. And the problem is about the user experience. Like in this moment, every time we have to send a transaction, we are really scared about it. And we are the technical people or people in the world. So let's just try to imagine other non-tech people, what's going on in their mind when they have to approach this system of sending transactions. So basically, these are the three main problems of why today's transactions are very difficult to interact with. So the first problem is that it's actually not a problem. Like for many people, it's seen as a problem, but this is not actually a problem, because I don't know how many of you knows about the blockchain trilemma. So basically, when you create a blockchain system, you always need to choose between scalability, security, and decentralization. And Ethereum decided to not scale directly, to not choose to focus on scalability directly. So later we will talk about this. The second problem is about wallets. And basically, today for interacting with the blockchain, the only way is to have a public and a private key. And like for many non-tech people, this is like completely something new. It's like in other system, we have an account and we have a password, and with the password, we enter our account in the system. In Ethereum, it's not like this, like right now. In Ethereum, your password is your account. And if you lose your password, you're actually losing your account in general. And if you need to send a transaction, that's the only way. The only way is to sign the transaction with your private key. And if you don't know how to do it, of course, there are wallets that make this operation easier, but still not easy enough for non-tech people. And last but not least, the UI itself when we are sending the transaction. I don't know if you've ever sent a transaction and you checked what was going on underneath. Like in MetaMask, for example, you have this view that displays you basically some hexadecimal code, like just hexadecimal numbers. And of course, even for me, that I work exactly on hexadecimal numbers most of the time, it's totally incomprehensible what's going on underneath. So another reason why the non-tech user is completely lost while looking at a transaction right now. Okay, so let's begin with the first solution. As I already said, the main focus the main focus for Ethereum was not focusing on scalability, but it was focusing on the security and decentralization. Why? Because the entire Ethereum ecosystem chose to have layer 2s to focus to solve the problem of scalability. So basically, I don't know if some of you don't know what layer 2s are, but basically in the blockchain, in the Ethereum blockchain and in every blockchain, all the transactions are inside blocks. And there is a limit of the number of transactions that you have in the block. And the less block you have, I'm simplifying this, but the less block you have and the more decentralization and security improves. So that's why Ethereum is not fast, and that's why Ethereum it's pretty expensive, because not many transactions get into the block. And layer 2s, they simply groups many transactions, and they put many transactions into one single Ethereum transaction. That's all they do. They don't do not much else. And basically, you have several ways to do this. You can use zero knowledge, you can use other technologies, but basically, this is the simplest way to explain this. And of course, with layer 2s, since we have many more transactions into one single block, the speed and the speed is getting very the network itself is getting very faster, and the prices are completely almost subsent. So here we can see after dunk sharding that is something that the Ethereum ecosystem is working on. After dunk sharding is going to be implemented, we will Ethereum and with the layer 2s will reach more than 100,000 transactions per second. And also, this is actually a fee from Loopring in mid-April, and this was almost sub-cents. But we will get there. This is not too difficult. Okay, so the second problem was about wallets and having the private public key. How many of you have ever heard about account abstraction in general? Any? Yeah, okay. So here again, I'm going pretty fast. So basically, right now on Ethereum, the only way, as I said, the only way in which you can send a transaction is to have your own private key. If you don't have your own private key, you cannot interact with the blockchain at all. That's how it is right now. And with account abstraction, everything changes because developers can actually create new ways to interact with the blockchain. So instead of interacting just with the private keys, you can use these new ways that developers will implement to actually interact with the blockchain. And not just that, we can also delegate fee payment. So potentially when a new user is onboarding, she can actually start getting money or like joining the ecosystem even without having a zero balance. And also we can have batch interactions, batch transactions. So basically, instead of approving and then sending a transaction and then moving money from a smart contract, you can group all of different operations that right now you have to do manually, and the system will do it for you. So, but it's simpler with some examples. So first of all, this could be a good use in Naples for a smart contract wallet. So for example, if every day you go out to work and you always stop in the same bar, there is no need actually to have a transaction secured by a private and a public key. You can simply allow that specific bar to withdraw €1 at a specific time, like at a specific time, like I don't know, for example, from 8 to 9, that specific store can actually withdraw €1 from your wallet without asking for permission from anyone. And this could also lead to a subscription system directly on the blockchain that right now automatic subscription are very difficult to implement. So with account abstraction, potentially we could also have a payment subscription. And then, as I said before, it would be really easy for onboarding user to get started because again, right now, when you start and you need to use a protocol, because right now we just think about DeFi protocol. So yeah, I mean, user wants to get money to get started. But maybe in the future there will be many more different applications in which maybe crypto is not at their core. And so in this way, potentially a company or a DAO could potentially pay for the transaction themselves for the users. And also, this is what I like the most about account abstraction. Since the developers can create custom rules for authenticating a transaction, you could have different kind of rules for each situation. So as we said before, we could have like a automatic withdraw for €1 for the coffee, or maybe we could have a temporary token for while we are gaming. And so I don't want to sign a transaction while I'm gaming, of course. Like I want to buy an item, I don't want to sign a transaction. So potentially you could create, automatically the system will create a temporary token that, for example, for 2 hours from that specific computer, to that specific address, so like a white list of addresses, transactions are automatically accepted. And the last example is that is like one of the most important things right now. We actually suggest to people like from the Ethereum ecosystem to simply write down the 12-word phrase to keep your wallets safe, like, I don't know, on a paper. And that's like first rule when dealing with password is never write your password down. So it's, I don't know, like it's like living in a, I don't know, it's like giving bad advices. So with account abstraction, it will enable also for account recovering using multi-signature. And in general, using system in which you allow a set of people, maybe your parents or some friends. So instead of like right now, if you lose your bank account, you need to go to a bank and you need to trust that centralized entity. But in the future, potentially, you could just trust 10, 15 people that you really, really trust. And you need like for all of them to sign and to say, okay, he actually lost his wallet, so let's recover it. Okay. And so now we finally arrived to the third problem, the human readability of a transaction. And at Sourcify, we are exactly working on this. So this is a question for the developers. This is a trick question. So how would you implement a system in which to decode this cold data for any smart contract? So a generalized system to decode this cold data and get actually like the function name and the parameters name. No one is replying. Okay, so I just tried. So basically, most of the developers that I asked, they just go on Etherscan, they get the API, and they use some JavaScript function from famous libraries, JavaScript libraries to simply input the API and the cold data, and you get all the information that you need. It's called decoding the cold data. But there is a huge problem in this situation, that you're actually calling a closed source database, that is Etherscan, from a private company. Private company that could potentially get hacked and could potentially give you really bad information. So, as I told you in the slide before, many wallets are already doing this. So it's not true what I said at the beginning that all transactions are like this. I mean, not completely true, because still many transactions are like hexadecimal numbers. But the wallets are beginning to have are already beginning to have an interface like this one. Okay, so here is how at Sourcify, and it's not just the Sourcify in reality. This is like a plain Solidity. Like every Solidity contract, as I will show you now, as a hash at the end of the bytecode that you can use to actually fetch all the information that you need in a decentralized way without passing through Etherscan. I'm just showing you. Okay, so this is just a playground that we have to display the thing that I just told you. And here you can paste any Ethereum contract address. For example, now I'm using this deposit contract. Okay, so you can see that this is the whole bytecode. Basically, this is the binary of the contract. This is what's really going on under the hood. It's like this is the source code that is being translated into machine code that the Ethereum virtual machine can read. So, and here at the end, you have this, we call it aux data. Wait, I'm zooming a bit. Okay. Can you see? Okay. So, and inside this aux data, there is actually an IPFS hash that you can decode it. And inside this IPFS hash, you have the metadata of the smart contract, that it actually contains all the information of the smart contract, including the ABI. Okay, so this is like the proof that it's not needed to contact a closed database to get the information that you need about your contract. They are already available. And this is fundamental because, of course, I mean, many people are building decentralized application, and at the end, the final step in which they have to fetch the information to display them to the user, they're just fetching them from a private and closed database. That's like, why? Okay, so now we know this, but still, that final hash at the end of the bytecode, it's not like the developer can put any file, can link any metadata file. Okay, so you cannot simply take that hash at the end and use it to get your ABI. First, you need to check that the contract was actually built to give that bytecode that I showed you before. That's what Etherscan does when you click verify contract. Okay, and at Sourcify we do exactly the same thing. We are not a block explorer. Okay, so we simply verify contracts. So we just take the source code and we recompile it, and we check if the bytecode, if the deployed bytecode is equal to the recompiled bytecode. And in that case, we host all of your files for free on IPFS. So this is a very good way for like the final developer, the final wallet developer, to simply fetch all of your contracts files and then using them to display human readable information to the final user. Okay, and this is not enough right now because I just explained how let's say the ABI part of a contract call is handled in a decentralized way. We are actually working with MetaMask and Coinbase and many other wallets. We have this Telegram group if you want to join it, and if you want to track or collaborate or join this human readable transaction challenge. And so, for example, we are thinking about adding like emulating the transaction before actually sending it, and then reading the emulated transaction and give like a human readable explanation of what's going on and like which addresses are going, like which balances are going to change, what will happen. Or also there is an idea of using AI for actually reading contracts and explaining the contract, so what will actually happen to the user in a human readable way, and also displaying audits. So when interacting with a contract, you can also display all the audits for that has been done for this contract, and many other things that are going on, and still that the smart contract nowadays already have. So the human readable transaction is pretty complicated stuff, and there are many different entities working on it, and each one bringing its own feature. Okay, it will be many features grouped together, and at the end we will have finally human readable transactions. So at the end, after these three problems are solved, we will finally have a transaction with sub-cents fees, and it will take seconds to confirm them. We will receive a notification with all the details fetched in a decentralized way. and it will be secured by your preferred authentication method. And this is really like we pay nowadays for everything in stores. So we are actually working on this, and I think we will get there. So this is just a call for you, for both developers and non-developers, to join the ecosystem, so to join the hackathons, because like this is a really important moment for account abstraction, for human-readable transaction layer 2s, because this is really the time to focus on the user experience. And I said before, from the DeSci word, we techie people are not very good at user experience. So we really need the designers and other people. And in all hackathons, like it's not just hackers and it's not just developers. We really need non-tech people. Okay, so start supporting layer 2s. So let's start using layer 2s. And at the end, let's start contributing to open source projects. That's how actually I got into the Web3 world. Like I met Khan while working on open source, and at the end, I with one PR at a time, I started working on it, and that's how it went. Okay, so thanks for listening. If you want to go.
Question time, Joshua, yeah?
I think you answered it at the end, but can I join that working group and contribute with like potential ideas rather than, because I have no development experience at all or capabilities, I won't. Can I join that and offer some potential ideas with human readability for DeSci in particular? Is that still relevant?
Yeah, so this is a newly created group, and we are actually trying to start in some way. We just had one call. We gathered some of the big entity in the ecosystem. Of course, you can all join. I'll leave it here. And we really need someone that can help us to define like how to move forward. So, and also give, like, we are thinking about splitting the group into many teams. So maybe more techie people, more user experience people. So definitely.
How interoperable is Sourcify and something like Ceramic Network? It's off-chain computation for scaling. This is all on-chain, is that right?
Sourcify is completely off-chain, so off-chain. No, maybe him.
Right now, the Solidity compiler just either has a swarm hash at the end or an IPFS hash. So the Ceramic, does it work with the hashes? I don't know. But if the Ceramic hashes or anything is not yet implemented. So if, for example, in the future, the compiler does append the hashes of Ceramic, for example, then we can also support Ceramic Network. But for now, the only working general solution is IPFS.
So one of the focuses here is the human readability as well as the scaling of Sourcify, because Ceramics does scaling and we're kind of working with them, but there's no human readability at all to the transactions. And that would be a huge thing for a lot of researchers to be able to see the finite details. Do you think that's something that might be interoperable?
I think we need to look into detail what Ceramic is, but what we are referring to here is more about the readability of a transaction, an Ethereum transaction. I think Ceramic has a different transaction scheme. Yeah.
In general, we support all the EVM chains. So like we have a huge list I can also show you here. Okay, see you on okay, yeah, in the documentation. I don't know. Okay, so these are actually all the chains that we support, but just because it's more like the chain supporting, like the chains being EVM and supporting the hash at the end. So.
Since you talked about your talk's title is a transaction from the future, and I know that you are an AI big fan. How do you see? And I mean, up to 2 years ago, talking about AI and blockchain was just to forget it. Just let's talk about. But now it's like a thing. And how do you see AI interacting maybe within wallets to patrolling our activities on smart contracts?
So, I mean, I actually want to act this in Prague. So, yeah. I mean, okay, just steal my idea for ETH Prague if you want. Basically, I think that, I mean, first of all, for a human readable transaction, they can help a lot because they can just read the whole smart contract and they can explain to the user what will happen. But the main problem with these solutions is that they are now only running on a server. So it's not on your own machine. You cannot control what's going on. So potentially a malicious company owning like a huge AI could say, okay, when the user explain me this transaction, give him some bad information. So this is like the big problem with AI in general right now, that they are totally centralized. And I don't think it will be easy to decentralize them because they are very resource expensive.
Thank you. More questions? Okay. Thank you, Mark.